Alright guys, welcome to RC Mojo. This week we're going to put together the 3-speed gearbox for the Tamiya wrecker. We've built a couple before on the channel, but it's still worth going over again to keep the build nice and consistent. Right, we're on to bag D this time, which, not surprisingly, has all the gearbox bits in. We've got the end plates, the bushings, shift forks, lots of shaft and spline adapters, and of course all the nuts and the bolts. Step 24 then, the end plate with the motor mount. We're going to need a J2 bearing carrier, 3 of the aluminium tubes with the M3 holes at the ends, the rod with the threaded end, 2 flanged M3 nuts, 2 M2x6s, 2 M2 nuts, 3 M3x6s, and the end plate. We really need to pay attention to the orientation of the plate in the diagram. It's quite easy to put it together the wrong way round and not notice until you're quite well into the build. The main difference is the side of the small bushing that's pressed into the plate for the shift rod. The bearing carrier fits into the middle hole and uses the 2 M2 nuts in the hex-shaped holes, and the 2 M2 screws from the other side to hold it in. Every metal screw that threads into metal needs some thread lock. One loose nut can really cause some havoc with all the plastic gears. We will use the technique of fitting the screws, then popping a dab of thread lock on the exposed threads before undoing and retightening the screws to spread it around. The screws themselves don't need to be mega tight, just the usual bottomed out plus an extra little tweak. Next we have the guide rod for the shifter. It uses the flange nuts to attach, which on a good day will stay done up by themselves, but a little bit of thread lock really won't hurt. It's all metal, so we don't need to worry about getting any on plastic. We just dab some on the threads and spin on a nut. Pop it through the panel and apply a bit more thread lock. Spin on the other nut and nip it up so it's nice and tight. The last thing to do is attach the 3 rods using the M3x6s. Now for the time being we're just going to do them up finger tight. You can hold the screw in the panel and spin the rods on. Near the end of the build we're going to remove all the screws and thread lock them, but until the assembly is a stable structure we don't want to make anything permanent. Step 25, the shift rod and gear shaft A. First then we're going to need one of the plastic gears. Unfortunately the gears aren't marked, so you have to do a bit of detective work to work out which one you need. The manual says it's got 36 teeth, which is only useful if you actually want to count them. Instead we can say it's a larger gear and it has a splined inside that sits over one of the adapters. Most of the rest either have slots for the clutches or round holes for a bearing. There's also the 27-tooth plastic gear which has a hex hole in the middle. As far as the other bits go, we need the shift rod, 3 shift forks, 2 small springs, the 20-tooth aluminium gear, the 12-tooth aluminium gear which is also an adapter for the big plastic gear, a brass gear hub which is a splined hex adapter. Then we have 4 2mm and 6 4mm E-clips. And lastly, for the metal bits, we have 2 3mm washers. As we assemble, we're also going to need a J1 plastic spacer and a gear shaft. These shafts can look a bit overwhelming the first time you come across them, but as long as you take your time and match everything up, they do go together rather nicely. We'll start by clipping in an E-clip in the middle 2 slots in the shift rod, the 2 that are very close together. Next, with the shaft matched up with the diagram, we'll grease it up near the right hand E-clip and spin on a shift fork. Add some more grease, one of the springs, followed by a washer. Now while holding the washer back on the spring, we can clip in another E-clip. The shift fork should slide up and down smoothly without catching. If it does catch, now's the time to find out why. On the other end of the shaft we need to add some more grease. Slide on a fork, add the J1 plastic spacer. Now we might as well add a bit more grease while we're here. Another shift fork, yet more grease. Then just like the other end we add a spring, a washer and an E-clip to keep it all in place. Again the fork should slide up and down nice and smoothly. The gear shaft starts in the same way. We need to clip an E-clip into the two middlemost holes. Next we'll slide on the 20 tooth gear on the right side. First though, I've found the gearboxes are quite a bit quieter if you grease up the splines first. You don't need much, just a thin coat. On the other end we need to use the 13 tooth gear with the small step facing outwards. Again, grease up the shaft a bit first. Over the gear we'll slide on the plastic gear, again with a bit of grease. Then an E-clip goes on to keep it in place. Flip the shaft around and we can clip in another 2 E-clips. Slide the brass adapter onto the 27 tooth plastic gear and slide it onto the end of the shaft, followed by an E-clip to hold it on. These 2 assemblies now go off to the side so they're ready for when we need them. Step 26, gear shaft B. We're going to need 3 more gears, which hopefully are the last of them, so we can choose them based on size. There's a 30, a 37 and a 44 tooth, small, medium and large. For the metal bits we need the large 13x6 washer, 6 4mm E-clips, 2 silver hex adapters, 2 1260 bearings and 4 1150 bearings. There's the 3 clutches, J7, 8 and 6. It's important you keep track of which is which to make the build go smoothly. The easiest thing to do is put them down on the manual next to the stage where they go. It's also absolutely critical that you clean up all the plastic where the clutch is attached to the parts tree. It needs to be nice and smooth so nothing catches where it shouldn't. Also, part way through we're going to need the J5 plastic spacer, and of course we're going to need the gear shaft B. Right, the first part of this step is a bit of a debated topic. We're going to be using bearings, but it's debatable whether it's really a good idea. If we pop a bearing into the J7 clutch, it just falls straight out. Tamiya has us use bushings and glue them in place. The thing is, as well as turning on the shaft, they also need to slide back and forth. The bushings are okay at this, as long as they're greased up well. Bearings though really aren't so great at sliding, being steel on steel. However, unless you're constantly changing gear, that really is a minor point. They're going to be spinning more than sliding, which just leaves the falling out problem. Now, we don't really want to use any glue and accidentally gum up the bearing, so we need to be a bit more creative. The trick is to score the inside of the plastic clutch in a crosshatch pattern using the back of a blade. Each score will very slightly have a raised edge. With enough of them, the bearing will end up being a very tight fit with no glue needed. Prep and fit a bearing in both sides and it's ready to fit. Right, with the shaft lined up to match the diagram, we can start the assembly. In the middle we need to clip in an E-clip, then to the left we add some grease to help the bearing slide on the shaft, also to help keep things nice and quiet. Slide on the clutch and add some more grease behind it. Clip on an E-clip to stop it falling off and give it a quick test to make sure it slides up and down and rotates nicely. On the other side of the middle E-clip we're going to add some more grease. An 1150 bearing ready for the 37 tooth gear, and some more grease to the clutch so when we put the gear on it'll spread itself around. The Tamiya gearboxes are rather easy going when it comes to grease. You can really go pretty crazy with it and they're still going to work a treat. Slide the gear on so the clutch engages and pop another bearing on the other side. Clip in another E-clip and that's the first clutch fitted. Spin the shaft around for the next stage where we fit the J8 clutch and the 44 tooth gear. As usual we're going to grease up the spline first, then slide on the large washer. Follow that with one of the silver hex adapters. Grease it up so the clutch can slide along it, not forgetting to grease up the clutch too. Add some grease to the shaft and slide on a bearing. Add the gear and another bearing. To keep it all together we slide on the J5 plastic spacer with an E-clip on the end. On the left side of the shaft we need to grease up the spline and slide on another silver hex adapter. Grease up the hex and slide on the J6 clutch. Again, don't forget to grease it up. Add a bearing and slide on the 30 tooth gear so the clutch can engage. Another bearing and another E-clip. Double check you haven't missed any bits that need greasing. They're a lot easier to get at now rather than once the shaft is in the gearbox. Step 27, bringing it all together, which is always a bit of fun. We need 4 1150 bearings, 2 small springs, 5 M3x6s, the 4th rod with the M3 holes at the ends, 3 J3 plastic bearing inserts, and the other end plate. Okay, we're going to start with the plate with the motor mount and pressing one of the plastic inserts from the inside. Then press a bearing in. In the top bearing, we need to insert the shaft without the clutch's big gear first. The second shaft is a bit more interesting. We can't just fit it because we need the shift shaft too. If we're going to follow the manual, we need to add one of the small springs to the end of the shaft and engage the forks with the clutches, which is easier said than done. Except we're not going to add those extra springs. As long as you set the endpoints nicely, they're really not needed. They just add extra strain to the shift servo in first and third. You can add a small spacer instead, around 2mm thick, to make sure you don't overdrive the system. Then we can insert the gear and shift shaft into the plate. So far so good. At the other end we drop a bearing onto the ends of the 2 gear shafts, then pop a bearing insert over the top. Following the manual, we then add the other spring to the shift shaft, but we are of course going to skip that, which just leaves offering up the end plate. We need to align all 3 shafts and make sure everything's fully seated. Usually there will be a bit of wiggling required just to get it all lined up. When it's all in, we can loosely fit 3 of the screws into the existing rods before adding the 4th with the last 2 screws. We're not going to grease up the gears just yet, as we've still got a few bits to add, and it's so much nicer when you're not constantly getting covered in grease. Step 28, the motor. Now the kit does come with this very nice looking motor, and rather than the traditional 27 turn silver can, it's 35 turns, which will slow the truck down quite a bit. But while I haven't tried it, it's likely to still be way too fast for a truck being built primarily to use on an indoor layout. Instead, we have a Carson Poison motor, which is 80 turns. In third gear, it's still going to be plenty fast enough on a layout, but still have fine control at low speed. Right, for bits we need 2 M3x6s, an M3x3 grub screw, an M3x4 grub screw, a 3mm washer, 2 2mm E-clips, then we have the shift arm, drive cup, 10-tooth pinion, and a 4mm ball end. Also there's the fibre plate that sits between the motor and gearbox. I'm never quite sure exactly what it's for, but Tamiya have used them for a long time and there doesn't seem to be a negative to fitting them, so why not? Lastly, there's the J4 spacer. First we're going to attach the drive cup just to get it out of the way. We'll use a bit of thread lock on the M3x4 grub screw and thread it into the drive cup a couple of turns. Next we slide on the spacer to the output shaft and follow it with the cup. Line up the grub with the flat on the shaft, gently press the cup on and tighten the grub screw so it's nice and tight. On the same end of the gearbox we need to clip in an E-clip at the end of the shift rod so it can't be overdriven too far. Then on the other end of the gearbox we clip in another E-clip on the other end of the shift shaft. Next we have the shift arm to fit with the ball end. We need to add a little bit of thread lock on the threads of the ball end and thread it into the arm a couple of turns. Slide it onto the shift shaft so the brass bit is on the shaft and the hole in the steel plate is over the fixed rod. Tighten up the ball end, being careful not to damage it. You will need a spanner or some parallel pliers to tighten it up fully. Be careful though, with lots of leverage it wouldn't be too difficult to strip the threads. Motor next, and we need to add some thread lock to the small grub screw and screw it into the pinion a couple of turns. Pop it onto the motor shaft, lining up the grub with the flat and tighten it up just enough that it's going to stay put. Press the fibre plate over the bearing in the motor, line up the holes and offer it up to the gearbox. On one side we have a hole where we need to thread in one of the M3x6 screws, doing it up just so it takes up the slack. On the other side there's a slot so we can adjust the mesh. This time we're going to use a washer under the screw and again just take up the slack. To set it up, first we need to position the pinion on the motor. Ideally we want the teeth to be central with the plastic spur gear, but do watch out. You might need to have it a little bit further onto the motor than might be ideal. The grub screw can catch on the spur gear, causing a high speed ticking when the truck's running. Make sure there's a bit of clearance, then tighten up the grub screw. To set up the mesh, we want to have the screw in the slot fairly loose and the other screw just tight enough that the motor's held in place, but you can still move it up and down. We need to adjust it so there's a little bit of backlash between the pinion and the spur, spinning the gears and retesting until there's no tight spots. Then fully tighten the screws and retest again. When you're happy with it, grease up the gearbox. We want to add grease to the gears, turning the output shaft to spread it around. Keep going until it's nice and evenly distributed. Add some grease to the slots in the clutches and give the gearbox another spin. After a few rotations, you should feel and hear the gearbox smooth out as everything gets lubed and settles into place. Listen carefully for any clicks or ticks. If something's not quite right, this is your last chance to fix it before it all gets sealed up. Step 29, the gear case. We're going to need B1 and B2, the gear case halves, 5 M3x8s and 5 M3 plain nuts. This is really easy to put together. The halves just offer up to the gearbox and we use the nuts in hex-shaped holes and the screws in from the other side. Nip them up and that's about it. Except that we'd need to add some thread lock too. However, in this case it's far better just to swap out the plain nuts for some nylocks. The M3x8s are just long enough for it all to work. The gear case is also the mounting for the gearbox to the chassis, so all the torque is transferred through it. Or more to the point, we don't want the thread lock to eat away at the plastic around them. Once the two halves are together, we need to one by one remove the M3x6s, attaching the internal rods to the end plates and thread lock them. Initially, when reinstalling the screws, just take up the slack. Then once they're all back in, go from one side to the other and nip them up properly. When done, you should have a really solid feeling gearbox that's ready to fit to the chassis. Step 30, attaching the gearbox. We're going to need 6 M3x6s, 2 small rod ends and a small 2x45 rod. Just to get it out of the way, we're going to sort the rod out first, and as usual the manual tells us the measurement between the inside faces of the rod ends. In this case it's 35mm. So all we do is thread on the rod ends and set them so we've got 35mm between the inside faces. Simple. Next we'll attach the second steering servo mount, which is actually only being used to fit the side bits of the body. It's a full-blown servo mount though, which is why I'm tempted to see if a 2 steering servo setup might be an easy mod. Anyway, to fit it we need the chassis so we can offer it up and thread in the 2 screws. Then from the back we'll apply some thread lock to the exposed threads, loosen the screws a little bit and retighten. Next the gearbox goes in, and you need to use a technique where the side with the shift rod goes in first, then you kind of rotate it into place. It can take a few tries to get it just so, but it will go in without having to use any force. Slide the gearbox as far forward as it'll go, then slot in the prop shaft between the axle and gearbox. Then slide the gearbox back so it's lined up with its holes. The gearbox gets fitted with the last 4 screws. Now it's debatable whether to use thread lock or not. On one hand you're going to be into the metal chassis, on the other hand it doesn't take much to compromise the small plastic lugs. I've seen a few with the lugs missing, usually due to thread lock eating away at the plastic. A plane and a shake-proof washer might be a good idea, but I still haven't found a solution that I really like. The last thing to do is clip on the shift rod. Now the rod ends just press over the balls. At the gearbox end it's a bit of a fiddle to get at, so something with a flat end to press it into place is quite handy. At the servo end you can just press it in place with a thumb. And that's about it. One 3-speed built and fitted. As long as you take your time and keep an eye on the diagrams, you'll end up with a smooth, quiet and reliable gearbox. Next time we'll be building a second chassis, which should be fun. Right, as always, thanks for watching. Like if you liked, subscribe if you haven't, and leave a message if there's something on your mind. Bye guys!